We were promised a cheat code. Vendors told us that 1 million token context windows would solve everything. They said sheer capacity would give us perfect coding copilots and autonomous agents that remember everything. But the reality? It has been less cinematic and more catastrophic. The million token myth is dead. If you are building AI agents today, you know the pain. You stuff the prompt and the model gets slower, pricier, and more confused. Google has finally called the bluff. Their latest research reveals that treating context like a bottomless chat log is a fundamental architectural error. Today, we are breaking down Google's new context engineering pattern and why it changes everything about how you build AI. Here is the physics of the problem. 3 hard limits are smashing the just stuff the prompt strategy. First, the cost and latency spiral. Every extra 100,000 tokens pushes your cloud bills up and makes your agent lag. Second, the lost in the middle phenomenon. Models consistently ignore instructions buried in the center of massive prompts. And third, simple overflow. Even 1 million tokens isn't enough for a production agent running for days. Google's answer isn't 2 million tokens. It is an architectural pivot. They are no longer treating context as a mutable stream. Instead, they are treating it as compiled code. Think of your raw data, your sessions, memories, and artifacts as source code. You need a pipeline that compiles a minimal, task-specific executable for every single model call. This is the core of Google's Agent Development Kit, or ADK. It shifts the job from prompt engineering to systems design. The ADK breaks your agent into 4 distinct layers: working context, session, memory, and artifacts. This isn't just theory, it is a strict separation of storage from presentation. Let's look at how this actually works in production. Principle number 1. The session is your database. The working context is your query. In the old way, you just kept appending text to a string until the model choked. In the ADK, the session is a persistent, authoritative ledger of every event. But the working context? That is a disposable snapshot built for exactly 1 LLM call, and then immediately thrown away. Think about the power of that separation. You can log thousands of user events in the session, but only compile the last 3 relevant messages into the working context. This solves the lost in the middle problem because the middle effectively disappears. Irrelevant history never even enters the prompt. You aren't fighting the token limit. You are budgeting it. This brings us to principles 2 and 3, building an AI assembly line. Instead of string concatenation, you use explicit transformations. These are named processors like summarize sessional or select relevant artifacts. You define a flow where data is fetched, ranked, compressed, and injected. Because these processors are explicit code, you can actually unit test your context. Imagine debugging an agent. Instead of asking, "Why did the model hallucinate?" you can ask, "Which processor injected the wrong data?" This creates a predictable system, and it is secure by default. The ADK uses scoped context. A tool function gets a different view of the data than a user-facing reply. No single part of your system holds the entire 50,000 token history. Now, let's talk about the heavy lifting: artifacts and memory. Artifacts solve the giant file problem. PDFs, CSVs, and images are stored once and referenced by ID. You don't paste a 50-page document into the prompt, you pass a reference. The model calls tools to read specific chunks when it needs them. This keeps the working context lightweight and fast. Then there is memory. This is where long-term knowledge lives: user preferences, company policies, and past decisions. The ADK allows the agent to search memory and pull in only the top 3 relevant facts. It is the difference between an agent that has to reread a manual every time and one that actually learns. So, what does this mean for you? The era of the prompt engineer tweaking words in a massive text block is ending. We are entering the era of the context architect. Your job is to design the pipeline, define the scopes, and write the processors that compile the state. You are building software, not just writing prose. Google's context compiler approach proves that throwing more compute at the problem isn't the solution. Smart engineering is. If you want to build scalable agents that don't bankrupt you, stop feeding them endless tokens. Start compiling their context. I'm diving deeper into the ADK code in my newsletter this week, breaking down the specific processor functions. Check the link in the description. If you found this breakdown valuable, hit subscribe and let me know in the comments. Are you still chasing the million token dream, or are you ready to start architecting? Thanks for watching.